So what are the motions that we're going to need for the mouth? Well, the motions we're going to be talking about are opening, closing, side to side, and then sort of a forward and backwards. So first off, how much of this should we actually expect? Well, typically someone should open about 40 to 50 millimeters. Now, we use millimeters because overall the range isn't massive, so it's good to have a measurement that can depict small changes. In order to eat, it's stated that you only need about 18 millimeters, but we consider more functional range to be about 35 millimeters, or 3 fingers of your dominant hand in between your teeth. Now, there can be differences between sexes in general. Guys are usually 40 to 45 millimeters, and ladies are 45 to 50. Now, going back to that 50-50 rule we were talking about in terms of the percentage of sliding versus rotating, it's stated that about 11 to 25 millimeters of the opening of the mouth is coming from that swinging portion, or the bottom of the joint. When we talk about side-to-side motion, or moving that chin left and right, it's usually about 8 to 11 millimeters, so very tiny. We'll talk about later in the how do you identify problems video on how you can measure this actually. But if you're going to roughly ballpark it, the distance is roughly that of an incisor. So if I was going to move my chin to the left and I just look at a space between teeth, it should move to the next space. It should move the width of a tooth. Now, another way to think about this is that normal side to side is about 1/4 of whatever your opening is. So if you can open 40 millimeters, you should get about 10 either side. Now, you can also push your jaw forward, getting your bottom teeth out in front of your top teeth, and this is usually about 6 to 9 millimeters. And then you can pull it back, and that's usually about 3 millimeters. Now, none of these motions are really possible if both joints on either side aren't working together in concert. That's one of the other unique things about this region is that you have 2 joints simultaneously working in order to make this occur. So let's talk about the actual muscles that are going to be producing these motions. We'll get back to what's happening at the joints individually, but let's really focus in on these muscles. So we have a lot of power in this area when it comes to closing the mouth. But should we have this much power? What type of lever is this joint? Well, I know, I'm starting to lose you now because we're talking levers and physics, but it's actually really good to know about how levers work. So you have 3 types of levers, 1, 2, and 3, and then we have 2 terms we really need to focus on, which is advantage versus efficiency. Now, what differentiates levers from each other is where is the load, where is your effort, and where is the fulcrum, okay? If you know where those are, then you can determine what's the advantage and what's the efficiency of that joint. So looking at a class 1 lever, what you have is that's in essence a seesaw. You have a fulcrum in the middle, you have the effort you're putting or the force you're applying on one side, and you have the load you're trying to lift on the other side, okay? Now, what makes this advantageous or gives advantage to the lever or not is going to be the distance that the force you're applying or the effort is from the fulcrum, and what's the distance that the fulcrum is from the actual load. If the load distance is shorter than the length that you have or the distance it is from the effort, then you have advantage. And we've all seen this when we're actually trying to lift something. If I'm trying to turn a screwdriver, or if I'm trying to use a hammer to kind of ply up a nail, I want a longer arm, right? That longer arm, as farther I am and where my effort is away from whatever I'm doing, gives me advantage, gives me a mechanical advantage. Now, if we look at a class 2 lever, what you see here is that it's the wheelbarrow. Your effort is here. Your load is in between it and where the fulcrum is. Now, because the load is in between where the effort is in the fulcrum, that means that its distance to the fulcrum will always be smaller or closer than the distance where the effort is being applied, which means our idea of advantage is a class 2 lever is always advantageous. You always have an advantage in terms of lifting it. What about a class 3 lever? Well, a class 3 lever, it's kind of the opposite of that class 2. You have your load that you're trying to lift, then you have your effort, then you have your fulcrum. So this means that because the effort is in between the load and the fulcrum, you never have advantage. It's always going to be closer or have a shorter lever arm or a shorter distance to the fulcrum than the actual load you're lifting. So why does the body use class 3 levers all over the place? The biceps, the TMJ, why do we use it? Well, that brings us to the other concept that we need to know, which is efficiency. If I have an area that's closer to the fulcrum and a load that's further away. That means that if I can only move this far over here, I'm going to travel this much distance at the load. That's what it means by efficiency. It means that a small amount of movement, not effort. You still, because you have lack of advantage, you need strength. But if you can only produce, say, 2 inches or so here, you might produce 5 inches of movement here, and it's going to be a faster movement than what you're moving here. That is efficiency. So the body uses that, and we just create powerful muscles to perform it because they know that it's not advantageous. But the output, the efficiency of we produce a lot of motion from a little motion, that's what's beautiful about these. And you can see this by the sheer size of these muscles that are going to be pulling up. They're producing that power so that they can utilize the efficiency of these joints. So we have one of these muscles that's this large fan-shaped muscle that on either side of our head that goes from behind the ear towards the eye. And you have this arch on the side of the head that if you ever happen to look at a skull and look down in it, this arch is pretty wide. And this muscle is going to fill that entire space as it heads down towards the jaw. And because it fills that entire space, it's pretty thick, even though it looks like a thinned out fan. Then coming off of this arch, you have another muscle, another thick muscle that runs down to this angle of the jaw right back here. And it starts to create this little sling or this hammock under the jaw because you have a mirror image muscle, more of an internal muscle, medial to the jaw or inside the jaw that is mirroring it and coming down, and together they're creating this hammock sling underneath this angle back here. And that means that they can really pull up and snap shut this jaw. So all 3 of these muscles together are going to create this closing or elevation.